Let us check the next number, that is problem number 25. Two different coils have self-inductance L1 as 8 millihenry and L2 as 2 millihenry. The current in one coil is increased at constant rate. The current in the second coil is also increased at the same rate. That means rate of change of current, that is di by dt, is same in both the coils. That's what he is giving us in that wording. At a certain instant of time, the power given to both the coils is same. This in fact is the main clause based on which you just have to tackle this problem. So given that at a certain instant of time, the power given to both the coils is same. That in fact is the main concept based on which we people have to tackle this problem, I said. At that time, the current, induced voltage and the energy stored in the first coil are I1, V1 and W1. And in the second coil are I2, V2 and W2 respectively. Then he is giving us four different options here. One is I1 by I2 is 1 over 4. That's 1:4. That is the ratio of currents. And second option he has given I1 by I2 is 4. So you can understand that I1:I2 is 4:1 according to the option 2. And coming to the third option here, W2 by W1, that is energy stored in the second one divided by energy stored in the first one. That is given as 4 again. And fourth option he gave, V2 by V1 is equal to 1 by 4. So that is V1:V2 is 4:1 ratio he is talking about. This question has been asked in one of the papers earlier as multiple answer question like. So we have three different answers correct over here. A is correct, C is correct, and even D also is correct. So in what manner we just have to tackle this model? He is talking about two separate wire coils, inductances L1 and L2. L1 is given 8 millihenry and L2 is given 2 millihenry. Fine. But what is the important most clue he is giving us in that problem? At a certain instant of time, the power given to both the coils is same. That's what he is talking. So I can directly write power 1 and power 2 are going to be equal. But in true sense, we know very well energy, when I consider that one as W, that is half Li square, then you can get power is equal to dW by dt. That of course we can write like this, half L into 2I di by dt. That is the equation out of which 2 when you cancel it off, power now becomes Li di by dt. This is the formula finally you people have to remember for the power that is entrusted to one of the coils over there. Now according to the problem given, power of the first coil and power of the second are equal. Then we can directly write this way, power 1 and power 2 are equal means L1 I1 di by dt, that is for the first one, L2 I2 di by dt for the second one, they are supposed to be equal. But very clearly he is mentioning in the problem, the current in the second coil as well as the first coil, they are increased at the same rate. That means rate of increasing the current, what you are observing there, that value is same for both of them. When di by dt for the first coil as well as the second coil, when they are equal, you are left with now simply L1 I1 is equal to L2 I2. Therefrom you can estimate what is the ratio of currents passing through both of them. I1 by I2, that now becomes L2 by L1. L2 according to the problem is given as 2 millihenry and L1 is given as 8 millihenry. We know L1 is given 8 millihenry and L2 is given 2 millihenry. These are the values of inductances what have been provided to us. So directly L2 by L1, which now becomes 2 over 8, that now becomes 1 by 4. So the ratio of currents across those two coils is 1:4. Look at the first option, he gave I1 by I2 is equal to 1 by 4. In the second option, he gave I1 by I2 is 4. So second option is not correct. Certainly the first option, that is A, is correct according to this one, first thing. But he has given you two other options as well. One is W2 by W1 is equal to 4. So let us try that one, whether that is correct or not. W2 by W1, when I write half L2 I2 square by half L1 I1 square, half getting cancelled. L2 by L1, it's 2 over 8. Till that extent, okay. But I2 by I1 is 4:1. Square it up. 4 square is to 1 square means it is 16 over 1. So this goes once again twice. So you will be getting 4. So W1 by W2, sorry, W2 by W1 is given as 4 for us. W2 by W1 is 4, he has mentioned in the third option. So once again you can understand here the answer is C also. Answer A is also correct. We have already seen that. And C also is correct according to the calculation given. Now check the fourth one. What is he asking for? V2 by V1 is equal to 1 by 4 is the fourth option given. What are V2 and what are V1? You can understand directly. They are the potential differences across the system. So truly speaking, when we talk about V2 and V1, V is equal to IR, we can write it directly. So out of that one, you can even take power is equal to V square by R like also. So V1 by V2 or V2 by V1 in this particular case, what he is talking about, that will be, if you calculate V2 over V1, that again you will be getting 1:4 like. So what we people can understand in this particular case is V2 by V1 is 1:4 is correct. That means the option is going to be fourth one as well. C is correct, D is correct and A is also correct. Then what can we directly understand? So if you take the complete option for this one, the answer, it is A, C and D. All the three are correct excepting the second option, which is given as B, that is I1 by I2 is equal to 4. Excepting that, all the other three options given are correct here. That means such a kind of a question also can be expected, as you all know, in JEE. So multiple answer type of questions whenever they give, it is a minimum thing that is required for all of us to check each and every option what has been provided to us. Then only you will be in a position to identify all the right options or correct options over there, barring those ones which are wrong enough. So this is the very first problem, of course, in this order, that's 25th problem, that has got 3 correct answers out of the options given. A is correct, C is correct, and D also is going to be correct in this case. So this is the ultimate answer for this problem 25. Let us switch over to the next problem, that is 26. A conducting square loop of side L and resistance capital R moves in its plane with a uniform velocity v perpendicular to one of its sides. Magnetic induction B constant in time and space. Observe that wording, magnetic induction B constant in time and space, pointing perpendicular to into the plane of the loop, exists everywhere. Then the current induced in the loop is how much? He has given us 4 options. Before that, let me just show you what is the figure corresponding to that. You can check that one first. He is just giving us, there is a loop like this. That loop is now moving with a constant speed v. In a magnetic field this way, the magnetic field has been given perpendicularly inward. The direction of this magnetic field is perpendicular, no doubt, to the motion of this loop, and it's directed into the board over here. Likewise, when you draw the same picture on your book, it's perpendicular to the paper, direction that is directed into the paper. That is what actually has been given here. This is the magnetic field what he is talking. And velocity of this particular loop, he just has mentioned that it is v, it is now moving across this magnetic field like. Now what is his question? Then the current induced in the loop is how much? No doubt question is looking a little lengthy, but if you think carefully, you can get the answer very easily. 4 options are mentioned once again. Let me read them out first. First option is BL phi by capital R. Direction is clockwise. Second option is, that is BL phi by capital R, anti-clockwise. You can understand in this case, B is magnetic induction, L is the length of each side of the loop, what he is talking about a square loop, and phi, that is the magnetic flux. Now come to the next one, that is the third option, 2BL phi by capital R, anti-clockwise. And fourth option, he gave it as 0. Now just a little carefulness in observing the question and understanding the very meaning of the second sentence, you can get the correct option there. Magnetic induction B constant in time and space, pointing perpendicular into the plane of the loop, that is existing everywhere around that. That's the point what he is talking. And in fact, we all know the basic of this electromagnetic induction chapter. Whenever there is rate of change of magnetic flux, then only we used to observe induced EMF across the terminals of that loop or that wire or that conductor what is just moving across. As long as the field, that is magnetic field, that is constant is concerned, there will never be any amount of induced EMF produced. So what we should understand in this particular question is, he is telling magnetic induction B constant in time and space. That means what? It is not at all varying with respect to time. Unless the magnetic field is a varying field, we never used to get induced EMF. When we are not getting induced EMF, it's very, very clear indication that there will never be any induced current corresponding to that. So what is understanding? As long as the B value is constant is concerned, as long as its value is not varying with respect to time that is concerned, there will never be induced EMF, there will never be induced current. So what must be your answer? The current induced in the loop is the question. Our answer is simple, 0. There will never be any induction, any induced EMF or induced current. So what is the logical concept you can understand here? Right, when d phi by dt is 0, when there is no change in magnetic flux with respect to time that is concerned, then automatically we can understand induced EMF will be 0. That implies induced current also will be 0. So our answer is going to be this. Therefore, the correct option that's going to be D for us. So if it is a varying magnetic field, flux variation is possible with respect to time. That rate of change of flux, if at all it is there in the system, automatically EMF is induced and current also is going to be observed as induced current. So in this problem, after reading the second sentence itself, you can come to a straight conclusion that there will never be any induced current across the loop as far as this point is concerned. So for question number 26, the correct option is D, which of course gives us induced current as 0. That is the concept of 26th. Let us check the next number, that's problem 27 now. A vertical copper disc of diameter 20 centimeter makes 10 RPS about a horizontal axis passing through its center. All of you are familiar with 10 RPS is the linear frequency of that body. Then how to just convert that one into angular frequency? You can understand it is 2 pi n. We people used to write 2 pi into 10, that now becomes 20 pi radian per second. Now check the next. A uniform magnetic field 10 power minus 2 Weber per meter square or Tesla acts perpendicular to the plane of the disc. Acting perpendicular to the plane of the disc means one can understand that the potential difference between its center and the rim is how much is the question. That will definitely be maximum. So what is the concept here? The potential difference between its center and the rim is how much? Another thing, what he is giving us 4 different options. First option is 2.14 into 10 power minus 3 volt. See the second option, 3.14 into 10 power minus 3 volt. Third option, 5.14 into 10 power minus 3 volt. And fourth option, simply 1.14 into 10 power minus 3 volt. The correct option for this one is 3.14 into 10 power minus 3 volt as such. What for you people can straight away understand? He is talking about its diameter as 20 centimeter. So first and foremost, when diameter is given as 20 centimeter, it's understood radius now becomes 10 centimeter, which can be written 0.1 meter. So that is one value what has been provided in the problem for us. And of course it is making 10 RPS, he said. So linear frequency over here is now 10 RPS. That implies its angular frequency, if needed, you can write 2 pi n, which now will be 20 pi radian per second as such. This is the corresponding value. If needed, we can use this formula also, that value. And what else he has given? Uniform magnetic field of 10 power minus 2 Tesla, that's B is given 10 power minus 2 Tesla. Straight away this is the data. Whether you directly remember or put them on paper, no problem. Now we want the potential difference between the rim, the center and the rim of that disk. That means first and foremost you need to know what is the magnetic flux. Then you can directly write d phi by dt, that gives you the induced EMF. That is what he is asking you to calculate ultimately. So what can we write now? First of all, phi is equal to BA. Thereby induced EMF we can write d phi by dt over here with a negative sign. So what can I write now therefrom directly? B into dA by dt I can write. That is the concept. Now how to calculate dA by dt? You can now understand this one is B, the magnitude only if you take, into what is this dA by dt? It is rate of change of area. For a disk or anything like that, when it is circular by shape, one can understand that is no doubt pi r square. Into what? Into the number of rotations that is made by this particular body in 1 second. So what are the values he has mentioned over there? Look at 10 RPS. That's the value what has been given to us. So 10 RPS he is talking. That means in 1 second it's making 10 revolutions. So pi r square is area into number of rotations made in unit time. That is the concept for dA by dt. What for we people are writing this way, you can better understand. dA, okay, is pi r square, fine. 1 by t means reciprocal of time period is called frequency. That frequency we can write it as a number of rotations made in unit time. So we have been given the value of B directly, that's 10 power minus 2 into pi is 3.14 into r square, that's going to be 10 power minus 2 into number of rotations it's making per unit time or in 1 second has already been given as 10 in the problem. So 10 you take it as it is. So this 10 gets cancelled here minus 1 time. So what are the options he has given? If you compare, you will be getting 3.14 into 10 power minus 3. What are the units? This is the potential difference between the center and the rim. So you can understand that will now be in volt as such. Now see the options mentioned. Second option is exactly the same calculated value we have got. Second option is 3.14 into 10 power minus 3 volt. Same value we have got. Therefore, we can say answer is going to be B for this. So all of you might have understood this particular conversion. There is no complication with this value given. B directly you can write. But d phi by dt when we talk about, dA by dt is one term we are going to come across. Out of that dA we can write pi r square being a circular disk like, fine. But what is this 1 over time? That 1 over time is nothing other than the frequency. Which frequency? Linear frequency. In other terms, number of rotations made by that body in 1 second as such. So automatically this now gives you the number of times it is rotating per second, which has been given as 10. Write down that value, simplify and get the answer what is required there. So for 27th problem, the correct answer is 3.14 into 10 power minus 3 volt, which is exactly the second option given in that order as such. That is problem 27 for us. Let us take problem number 28. One of the wonderful model questions for JEE like exam. Same model, same question in fact has been asked earlier also. A plane loop shown in the figure is shaped in the form of two squares with sides A is 0.5 meter and B is 0.3 meter and is placed in a uniform magnetic field at right angles to the plane of the loop. The magnetic induction varies with time as B is equal to B naught sin omega t, where B naught is 20 millitesla and omega is 100 radian per second. The amplitude of induced current produced in the loop of the resistance, if its resistance per unit length, that is 50 milliohm per meter as such, is how much? First option is 1 ampere, second option is 2 ampere, third option is 3 ampere and fourth option is 2.5 ampere as such. So what exactly the concept we people have to understand there? His concept is, first of all, if you see the figure, you can understand what exactly is his idea. He is just giving us a square this way. Three sides of the square I am talking. The fourth side is just taken this way. This wire has been taken over this. Another small square is connected over here. See the way he has just connected, it's all a single wire itself, there is nothing in that. But the way he has connected the system is now providing us two separate squares of different dimensions. And he has mentioned over here, this is of side length A. This is of side length B, like this he gave. And what are the values also he has provided us? The value of A is given 0.5 meter, whereas the value of B is given 0.3 meter. So these two are the dimensions of both the squares what he has provided. Fine. And what did he say? They are placed in a uniform magnetic field at right angles to the plane of the loop. That means the magnetic field is perpendicular this way. That of course you can understand from that. The magnetic induction varies with time as B is equal to B naught sin omega t. This is important for you. B is equal to B naught sin omega t. Already in one of the problems earlier we have discussed. Unless there is a varying magnetic field with respect to time, we cannot directly get induction or induced EMF is not going to be observed. Now what is he giving us? Look at B naught value he gave 20 millitesla and omega 100 radian per second. So B naught is given 20 millitesla, that of course 20 into 10 power minus 3 Tesla, and omega value directly has given 100 radian per second. In fact, these are the values given there. Now observe a little carefully here. Suppose if I say current in the first coil is now moving in clockwise way like. I am taking the direction like this. Now look at. Current is just entering this way, going this way, coming all the way like this and entering this way. Observe very carefully in this figure. In the first coil, if you find current is clockwise, in the second one, you are observing current is anti-clockwise. Look at this particular point carefully. He has arranged the system in such a way that if current in the first loop is clockwise, current in the second loop automatically will be in anti-clockwise direction. For example, if I take in the first loop, the current is in anti-clockwise direction, then automatically in the second loop, the current will be in clockwise direction as such. So due to this one, whatever the induced EMF values we are finding across both the parts of the loop are now to be taken with the difference as the resultant value. If EMFs are in the same direction, we can directly add them. But in this particular case, we just have to take the difference of those two values. That is one aspect you need to understand. And of course, we know the very first one, if I write EMF 1, that is d by dt of BA. In fact, d phi by dt formula, there is nothing special there. But what can I write here? This is now A. A is going to be A square. So we can write A square into d by dt of B naught sin omega t. That is the equation. What for I have taken A square, you can understand it is the first square I am talking about. Its side length is given as A, then automatically area becomes A square. Now if I simplify this one, I will be getting the value of E1 directly this way. B naught omega cos omega t it is, right? B naught omega A square cos omega t. That is the equation for E1 as far as the first loop that is concerned. So d by dt of B naught sin omega t now becomes B naught omega cos omega t. That only I have written. A square as it is being a constant, it will come out of that. Exactly in the same way, what will be E2 now? It's again the same formula, d by dt of BA. This time the area is B square. So I can write B square, once again d by dt of B naught sin omega t. If I rewrite the same equation here in terms of E2, what will I get? B naught omega B square this time cos omega t. This is the value of E2. Since the directions of currents in both of them are opposite, even one should consider the EMF values are also opposite like. So what will now be the net EMF here? I can directly write it as E1 minus E2. What will I get? E1 minus E2 means what is that we can take common? B naught common, omega common, cos omega t common. So what I can write directly? B naught omega cos omega t into A square minus B square. That is the value I can write. But one thing more you people can understand this way. In fact, E1 minus E2 I have taken. I do not know what are the individual values and other things like. But since A is more, I can take it for granted that E1 is greater than E2, that's all. Otherwise, difference we want, nothing else. Now, what will be the effective resistance of the system. You can all understand this is having A as its length. What is the total length of the square then? 4A. 4A meter if I take like, then he has mentioned resistance per unit length as 50 milli ohm. He gave that value. Resistance is given as 50 milli ohm per meter. So what will be the effective resistance now? This is 4A. This is 4B. This is the total length now. That into the given resistance. What is that resistance value he gave? 50 milli ohm per meter. You are getting this length in meter. For so many meters, how much is the resistance? So you will be getting the value of E net and the value of R effective. Taking these two, can't you just estimate what is the value of current now? I now is going to be the net value of EMF over the effective value of resistance in the system. So what is it you people are going to get here? Look at now, B naught omega into A square minus B square into cos omega t, that over this value 4 into A plus B into R, like I can write. If you carefully observe this part, can't I take it as maximum value of current into cos omega t like? I can be written as I naught cos omega t. What is that I naught now to be called? It is the maximum or peak value of current. That's one way of representing I naught. What is the other one? This is also called current amplitude. Amplitude refers to maximum value. So current amplitude, in other words, we can call that one as maximum current also. And his question is amplitude of induced current. That is what is this value. So what can we write now? Therefore, amplitude, observe this wording, amplitude of induced current, that now can be taken as B naught omega. Look at here carefully, A square minus B square by A plus B. Can't I just write it as A minus B? A plus B into A minus B, if I write the numerator, A plus B getting cancelled, A minus B is left over. So into A minus B over, what do you have here? 4R, right? This is the value of the amplitude. Out of that one, look at carefully. A is given 0.5, B is given 0.3, and the value of B naught is given 20 into 10 power minus 3 Tesla. The value of omega is given 100. R value is given 50 milli ohm. Every value he has provided. Just to substitute them all there, you will be getting the amplitude as simply 2 ampere. So what we should understand here, how to tackle the model. If you know simplification, of course every one of you can do that. That is not a big task. Being most of you people, of course, are very effective in mathematical calculations, like certainly you can all do that. That's not a problem at all for any of you. Only thing is you need to understand the basic concept behind that. So here 2 ampere will now be the total current amplitude, or you can call it or induced current amplitude or maximum induced current. Whatever you talk about, result is the same. So 2 ampere you will be getting there. Seeing the options, 1 ampere the first option, 2 ampere the second option, 3 ampere the third option, 2.5 ampere the fourth option, automatically the second option is going to be correct there. So you can write directly answer as B itself. That is the point. So, problem is an excellent model. Same question has been asked also earlier at IIT level. Only thing is, you need to understand how to tackle that particular model. What are the steps to be taken up? Okay, you may be feeling it is lengthy, like it's not lengthy. I have written every value given over there in a separate step like. When you work out on your own, it won't take much of a time, more than 45 to 50 seconds for you. So that is a wonderful model. Every one of you should be thorough with this kind of a model for JEE. Let us check the next number, that is 29. Even this problem also has been one of the IIT models earlier. So 29th problem, when I read it out, you can understand what has been given there. Two parallel vertical metal rails AB and CD are separated by 1 meter. They are connected at the two ends by resistances R1 and R2 as shown. A horizontal metal bar L of mass 0.2 kg slides without friction vertically down under the action of gravity. There is a uniform horizontal magnetic field of 0.6 Tesla perpendicular to the plane of the rails. When the bar attains terminal velocity, the powers dissipated in R1 and R2 are 0.76 watt and 1.2 watt respectively. The values of terminal velocity R1 and R2 respectively are. He is asking you three questions here. One, what is the terminal velocity of it? And second one, what are the values of both the resistances given over there as R1 and R2? Three values he is asking. The options are given this way. First option is 1 meter per second, that is the terminal velocity. 0.47 ohm and 0.3 ohm are the resistances. For the second option, 2 meter per second for the terminal velocity, 0.6 ohm and 0.3 ohm for the resistances. And for the third option, 1.5 meter per second as its terminal velocity and 0.2 ohm and 0.4 ohm are the resistance values. Come to the fourth option, 2.5 meter per second being the terminal velocity they are given and 0.3 ohm along with 0.2 ohm are the resistances given. But what we people have to understand here is, out of all the four options, the first option is the correct option for us. That is, terminal velocity is going to be 1 meter per second in this calculation, and R1 is going to be 0.47 ohm and R2 is going to be 0.3 ohm. These are the two resistances what have been mentioned in the problem. So let us first of all understand what is happening exactly over here. He has given us two parallel rails like this, they are vertical like this. A resistance is connected over here, another resistance is connected over here. This has been given as R1, this has been given as R2. The distance of separation between these two rails is given as 1 meter. Very clearly he is mentioning that value there. And what did he say again? He said a horizontal metal bar L, that is metal bar, he said that one as L. This is the horizontal metal bar. You can all understand straight away. This is the bar which has been mentioned as L here. Fine. And what did he say? Its mass is 0.2 kg. The mass of this particular metal bar is 0.2 kg. That's what has been mentioned. And perpendicular to this plane, there is magnetic induction. He has mentioned its value as 0.6 Tesla. The value of B is now given 0.6 Tesla. Observe that value given there. And he has given a wonderful condition in this problem. I once again repeat that part of the problem, try to understand it carefully. There is a uniform horizontal magnetic field of 0.6 Tesla perpendicular to the plane of the rails. Fine. When the bar attains terminal velocity, in fact, that is the clue for solving this problem. When the bar attains terminal velocity, the powers dissipated in R1 and R2 are 0.76 watt and 1.2 watt respectively. So what we can understand here now, power 1 is given 0.76 watt and power 2 that's given 1.2 watt. But when can we take these two? When the rod is attaining terminal velocity. That is the important most aspect of this particular problem. When it is attaining terminal velocity, what is the general conclusion? Its weight, which is acting downward, and the force that is due to the magnetic field acting on this rod, which of course is BIL, B-I-L, L being the length of this particular rod, like if I consider. If both are equal and opposite, if both are compensating one another, then only there is a possibility for that rod to have terminal velocity, which is called a constant value of velocity there. So what is the conclusion you should have here? Unless the resultant force acting on that body, that is the rod, is 0, you can never have terminal velocity for that rod. So the basic condition we just have to understand is that part only. So what can we write now? When the rod attains terminal velocity, when the rod attains terminal velocity, then what should be the condition? Weight must be equal to BIL. L being the length of that rod, whether you take a capital L or small l, hardly that matters. Now can't you understand I in this particular case is mg by BL. I am taking this one as BIL, that L is the length of the rod, capital I am taking, nothing else. Now if you write mg by BL, mass of that particular rod has been given as 0.2. And B value of course he has provided to you, that is 0.6. Length of that rod is going to be a meter, you can straight away understand that one. Because the distance gap between them is going to be 1 meter he has given you. And G value, if I take that one as 9.8, like this gets cancelled, this gets thrice. So you will be getting the value over here mg by BL, fine. But observe this point carefully, or else we can calculate the things later also. Sorry. We can calculate the value finally also. There is nothing in that. I will write all the steps first. If you take I is equal to mg by BL, what is this I now according to this? You can understand R1 and R2 both are now connected in parallel. Then the total current that is entering into the system should now be divided into two parts over here across R1 and R2. So what should I write now? I must be equal to I1 plus I2. So one point you have to remember is this. And second concept you people have to go for is I is equal to I1 plus I2. And what next he is talking about? When EMF across the system is constant, you can understand power 1, which is 0.76, is equal to I1 into E, and power 2, which is 1.2, that is I2 into E. So what I can write now? I1 by I2 is equal to 0.76 by 1.2. And according to these two equations, we know that I1 plus I2 is equal to mg by BL. So look at this equation, look at this equation. I1 by I2 we know, I1 plus I2 we know. Can't you estimate what are the values of I1 and I2 there? The moment you know I1 and I2, can't you estimate the resistance values there? How come? You can write that power 1 is equal to I square R. Calculate R1, calculate R2 from that. Directly you will be getting two resistance values over there. So you will be getting the value of I1 and I2 from these two. Then you can estimate R value, which of course is going to be I square R, like if you write P by I1 square, P1 by I1 square, P2 by I2 square. R1 and R2 you will be getting. And what exactly is the concept here? He is asking you one more value. What is the value of terminal velocity of that system? See the equations once again. I1 plus I2 we have got mg by BL. If you substitute the values here, you get I1 plus I2 as 49 by 15. Look at this. I write this as first equation and I write this one as second equation. Can't you just estimate from these two what are the values of I1 and I2? You will be getting the values of I1 and I2 from equations 1 and 2. Simplify them first. Then what else we want? We want R1, we want R2. What are the ways, what is the equation we can go for? The resistance part of it. If you take resistance over there, power P is equal to I square R or V square by R. E being constant, you can directly write R1 by R2 is P2 by P1. Calculate the values of R1 and R2 from it. Next case, what is EMF? EMF induced, if you take, that is equal to BLV. There is a formula like this. Whatever the induced value of EMF you people are getting, how do you get induced EMF over here? It is P1 is equal to I1E. After getting the value of current, you can calculate induced EMF. So induced EMF is P by that value of I1 is equal to BLVT. And what is that VT now to be called? Terminal velocity. So you can write directly terminal velocity is equal to P by BL I1. This is the formula for terminal velocity. So what are the 3 points you people have to understand? Look at carefully once again. I1 plus I2 we have got. I1 by I2 we have got. If you directly simplify these two, you will be getting the values of I1 and I2 first. So when you solve these two, we get I1 as 19 by 15 ampere and I2 will be getting 2 ampere. These are the values. The moment you have got I1 and I2 like this, substitute that value here, this I1, then you will be getting terminal velocity exactly going to be 1 meter per second. So terminal velocity is 1 meter per second, I1 is 19 by 15, I2 is 2 ampere. With this data, you estimate the values of R1 and R2. What will you get for R1 there? R1 now comes to be 0.47 ohm and R2 now comes to be around 0.3 ohm as such. So R1 is 0.47, R2 is 0.3 and terminal velocity is going to be 1 meter per second. These are the three values. Which option you are having all the three? Once again you check. Very first option has got the velocity terminal as 1 meter per second and R1 as 0.47 ohm and R2 as 0.3 ohm. So the correct answer for this particular question is going to be the first option only. So what you have to understand here is the condition for attaining terminal velocity first. That is, its weight must be equal to the force due to the magnetic field. First concept is that. So equating them, you write what is I first. But I is nothing other than the sum of both the currents across R1 and R2. So I1 plus I2 must be equal to I, which of course is equal to mg by BL. If you simplify this, you get 49 by 15. So I1 plus I2 you will get. I1 I2 you will be I1 by I2 you will be getting. Taking these two, simplify for I1 and I2. Then estimate the values of R. R1 is equal to E by I1. E already we people are getting it here. So if you take this one, E value you can calculate. So E by that I1 is R1. E by I2 that is R2. So R1 will be 0.47 ohm. R2 will be 0.3 ohm and terminal velocity when you just want induced EMF over there is BL into V. That is motional EMF what we people used to calculate in this case. So velocity terminal will now be the value of induced EMF by B into L, like you directly can calculate that value as 1 meter per second. A little lengthy model, but one of the very important models for JEE like exam. Therefore, be cautious and thorough with every part what we have discussed here. Correct answer for this question number 29 is 1 meter per second for terminal velocity, 0.47 ohm and 0.3 ohm respectively are for the resistances R1 and R2 given in that particular figure as such. So the correct option is A for this problem number 29. Check the next number now. That is problem number 30. Figure shows two bulbs B1 and B2, resistor R and inductor L. When the switch S is turned off, then he is asking you 4 options. First option is both B1 and B2 die out promptly. Second option is both B1 and B2 die out with some delay, slowly is understood. And third option, B2 dies out promptly and B1 with some delay. And fourth option, B1 dies out promptly and B2 with some delay. What is the concept? Of course, he has given a very simple concept, easily every one of you can understand. There is a resistor connected here and a bulb is here, this B1 given. There is an inductance connected here, another bulb B2 is connected here. And of course, here he has mentioned a tapping key like. That's what has been mentioned there. And on the other side of it, we are having a series of cells which of course can provide the required potential difference to the system. This is resistance, this is inductance. This one is the so-called switch what he is talking about, and the first one is given as B1, this one is B2. Now the concept is when you switch on, naturally the bulbs glow, fine. When the switch is turned off, I have left that one. Now what is his concept? will both of them put off abruptly, like faster, or both will take more time to come back to rest, or one puts off faster, the other one takes more time to be rather off, like? 4 different answers he is asking. Very, very simple. You all know well inductance. When you consider in any circuit, current grows gradually from minimum to maximum and current decays gradually from maximum to minimum. Abrupt growth and abrupt decay is not possible in the case of an inductance. Every one of us, we know that fact well. So if such is the case, what happens when you put it off? The bulb which is connected to the resistance, that dies out faster. Whereas the bulb which is connected to this inductance, that also dies out, no doubt. But it takes more time to come down, to die out. In the sense, B1, that dies out faster. That means promptly. So we can understand directly, B1 dies out promptly and B2 dies out with delay. What for? You can directly understand. L, of course, is inductance. When you consider, the current abruptly will never come back to 0 from maximum. It takes its own time, like. Slowly it decays, exponentially it decays. We know these points very well. Thereby, B1 which is connected to the resistance, that dies out promptly. Whereas the one which is connected to that inductance, it also dies out, but a little slow. That means slowly with some delay it dies out now. So what is the correct option there? It is D. That is the correct option now for us. D, when I read out, same thing he has given there. B1 dies out promptly, but B2 with some delay. That is the correct answer for us, because across the inductance, current decays exponentially. Abrupt decay is not going to be possible. Therefore, the option for problem number 30 is going to be D for us. Look at the next one now. Problem 31. In a car spark coil, an EMF of 40,000 volt is induced in the secondary coil. When the primary current changes from 4 ampere to 0, inductance of the secondary windings of this spark coil is how much? Options are given this way: 0.3 Henry the first option, 0.4 Henry the second, 0.1 Henry the third, and 0.2 Henry the fourth. And correct option here is the third one, that's 0.1 Henry as such. In fact, we know pretty well in this particular model question, induced EMF is M di by dt. You can understand now. What is that M called? Mutual inductance. Coefficient of mutual inductance is represented as M. Had it been self-inductance coefficient, we would have written L. Here two different coils we have. One is primary, one is secondary, he is talking. So certainly inductance, of course, is mutually that's going to take place. So mutual induction is going to be taken up. So when I look at this equation, E is given 40,000 minus M, okay. How the current is being varying, rather 4 ampere it has come down to 0. So how to write this value now? 0 is final value, 4 is the initial value. In what time he is just talking about? He has given you that changing from 4 ampere to 0. That is actually the case. The current, of course, is coming down from 4 ampere to 0 in 10 microseconds. That is the value of time that has been provided to us. 10 micro, 10 power minus 6. Now the moment you just multiply these two, you will be getting 4m by 10 power minus 5. Now cross multiply this one please. 4m now becomes 4 into 10 to the power 4 into 10 to the power minus 5. This gets cancelled. It now becomes 0.4. Then what will be the mutual induction coefficient? 0.1 Henry. That exactly the value there. So what you people should understand, E is equal to minus m di by dt, the formula. Out of that, di is coming down from 4 to 0. Therefore 0 becomes the final value and 4 becomes the initial value. So 0 minus 4 will now become minus 4. Minus into minus, that becomes plus. So automatically you will be getting m as 0.1 Henry. Out of all the 4 options, this option is exactly coinciding with C out of the 4 given there. So C option is 0.1 Henry, and this is actually the formula one should understand from it. This is problem number 31. Another wonderful model question has been given in problem number 32. One conducting U tube can slide inside another as shown, maintaining electrical contacts between the tubes. The magnetic field B is perpendicular to the plane of the figure. If each tube moves towards the other at constant speed V, then the EMF induced in the circuit in terms of B, L and V, where L is the width of each tube, that is how much? Options are given for first option BLV, second option with negative sign minus BLV, third option 0, and fourth option 2BLV. What is it he is giving us? Let me just give you in a brief manner. He is talking about two tubes like this, two U-shaped tubes. One more tube, of course, one tube is inserted in the other, like this we people are finding. This is one tube, that is the other tube. So if you look at this one, first tube is this, second tube is this. This is now moving towards it with a velocity v. This is now moving towards it with a velocity v. These two are now moving across. Across what? A perpendicular magnetic field. He has given magnetic field is perpendicular to both of them. Now once again we should consider motional EMF here. Observe very simply. When this velocity and this velocity are quite opposite to each other in directions, what will now be the relative velocity of the system? When they are opposite by directions, won't you be having twice the value like? Therefore, EMF, that is motional EMF, is going to be B, L, V. V to be written 2V. Then what will be your answer now? 2BLV. This is the concept. So if you look at once again, 2BLV is the fourth option which has been given in that problem. So what you should understand is both are U tubes only, one fitted inside the other, both are moving towards each other like with constant velocity, of course common value of velocity, V there and V here. So relative velocity, when it becomes 2V, automatically the induced EMF over here becomes now twice BLV. So fourth option is correct option for this problem number 32. Simple question, but only thing is based on the relative velocity concept it has been framed. That is question number 32 now. In problem 33, he is talking of a transformer. A step-up transformer works on 220 volt and gives 2 ampere to an external resistor. The turn ratio between the primary and secondary coils is 2:25. Observe this particular ratio first. N primary by N secondary, that's given as 2/25. 2:25, that is the value what has been mentioned. Assuming 100% efficiency. Efficiency 100% means that transformer is supposed to be an ideal most transformer. And what is the condition for an ideal transformer? Input power and output power are supposed to be equal. Input power, it is V1, I1. Output power, V2, I2. That in the sense V1 by V2 must be equal to I2 by I1, like we people used to write, that is a ratio. What is he asking now? Assuming 100% efficiency, the secondary voltage, primary current and power delivered, that means output power, are respectively how much? Options are given: 2750 volt, 25 ampere, 5500 watt. These are the three values given in the first option. Second option, 2750 volt, 20 ampere is current, 5000 watt is the power. Third option, if you look at, 2570 volt is EMF and 25 ampere is the current and 550 watt is the power. Fourth option, if you look at, 2750 volt as potential, that is voltage, and 20 ampere is the current and 55 watt is the output power. Out of them all, the first option is correct for us. 2750 volt, that is secondary voltage, 25 ampere, that is primary current, and 5500 watt, that is the output power. What are the values he is asking you? You see, once again, secondary voltage he is asking. So you can understand well, E primary is given 220 volt. What is E secondary? That is one question. And what is the second one he is asking you? Primary current he is asking. That means, what is I primary? The question. What is I secondary given? 2 ampere he gave. And what is the third one he is asking? What is power output? Power output means what? You can say E secondary into I secondary. So these are the three values I just want. Now see the formula what we can take up. N primary by N secondary is equal to E primary by E secondary is equal to I secondary by I primary. This is the general formula one has to remember for an ideal transformer having 100% efficiency for it. So if you look at this, come on, first of all, take these two. E primary by E secondary is 2 by 25. What is primary value given? It is 220. Secondary value I want. So E secondary is equal to 25 times E primary by 2. So what is E primary value? You just write 100 and that is 220 by 2. This goes 110 times. So what will you get in this case now? 2750 volt. So 2750 volt is E secondary. One value I have got. What is it we want? What is primary current? Come on, equate these two this time. What can we write now? 2 by 25 is equal to I secondary by I primary. And I want I primary. So we can write primary current is equal to 25 times secondary current by 2. What secondary current is given? That is 2 given. So into 2 by 2, this gets cancelled. 25 ampere will now be the primary current. So I have got secondary voltage and primary current. What is the third one he is asking you to calculate? What is output power? Power delivered. Delivered means what has been given out. So output power, when you take E secondary into I secondary. What is E secondary we have got? It is 2750 volt. And what is I secondary already has been given, that is going to be 2. So you will be getting 5500 watt. So if you just look at carefully, secondary voltage is 2750 volt, primary current is 25 ampere, and output power is 5500 watt. All the three are very much given in the first option for us. Therefore, the correct answer for this question will now be A as such. That is the concept. Problem number 34 also is based on transformer. A transformer has 200 turns in the primary and 400 turns in the secondary. When a battery of 6 volt with negligible internal resistance is connected across the primary coil, a current of 2 ampere is produced in it. Then the secondary voltage and secondary current are how much? First option 12 volt and 1 ampere. Second option 12 volt and 0 ampere. Third option 0 volt and 1 ampere. And fourth option 0 volt and 0 ampere. This is a wonderful question. What for? Transformer will never function on DC. Transformer works only on alternating current. It does not function on DC. But to tempt you people, he has given so many values in the problem. What are the values? First of all, you see there, has 200 turns in the primary. Number of turns in primary is given 200. Number of turns in the secondary, he gave that one as 400. That means from this you can understand it is step up transformer. Fine. But what did he say? Yes, the secondary, when a battery of 6 volt with negligible internal resistance is connected across primary. 6 volt battery is connected. Remember this wording. Battery provides DC. So on DC, transformer does not work. When transformer is not responding, where is the question of secondary voltage? Where is the question of secondary current? Then certainly you can understand E secondary will be 0, I secondary also will be 0. So what is the one and only point? One point you have to remember. Transformer works on AC alone. It does not function on DC. So what is your answer straight away? ES0, IS0. So which is the correct option given over there? Fourth option is given the same values. But don't try to write that formula NP by NS is equal to EP by ES is equal to IS by IP and calculate the values blindfold. When it does not function on DC, whatever the value let him ask, maybe output voltage, maybe output current, maybe output power, whatever it is, all values are zeros. So simple concept is 0 and 0, that must be the correct option for this, that is D. This is problem number 34. See the problem number 35. One of the wonderful models once again in this order. A straight conducting rod of length 30 centimeter having resistance of 0.2 ohm is allowed to slide over 2 parallel thick metallic rails with uniform velocity of 0.2 meter per second as shown. What is the data he has given? First of all, let me remind you. He has given you a straight conducting rod of length 30 centimeter. That's why the value 1, what has been mentioned. And of course, having a resistance of 0.2 ohm, that also he has mentioned. And of course, he is allowed to slide over 2 parallel thick metallic rails with uniform velocity 0.2 meter per second. That of course, the velocity he gave 0.2 meter per second. That is the data given in the first sentence. Fine. The rails are situated in a horizontal plane. If the horizontal component of Earth's magnetic field is 0.3 into 10 power minus 4 Tesla and a steady current of 3 microampere is induced through the rod, then the angle of dip would be how much? Angle of dip angle, which of course is one of the parameters of geomagnetism. If you take the options given, first option tan inverse 3 by 4. Second option tan inverse 1 over root 3. Third option tan inverse root 3. And fourth option tan inverse 1 over 3. That's what has been given. And what is the way he has mentioned the figure there? You just look at. There is a system given this way. Like this, he said. And he is telling us a small rod like is just moving over this. It's now moving with a velocity as written over here 0.2 meter per second. That's the velocity what he is talking. Horizontal component has been given. When the rod is just moving, vertical component of Earth's magnetic field is now going to be disturbed by that. Due to vertical component of Earth's magnetic field of Earth only, EMF is going to be induced across this particular rod. So what you should understand in this case is the current induced current if I take, is it not directly I is equal to BLV by R we people can write. So BLV by R. What is this B now? It is to be called the vertical component of Earth's magnetic field. That value you have to calculate for calculating the dip value over there. So you can understand straight away from this one, the value of vertical component of Earth's magnetic field is IR by L into V. What are the values given you see now? Current is mentioned as 3 microampere and resistance is given as 0.2. Length of that rod is given 30 centimeter, you write 0.3 meter. With what velocity was it moving? 0.2 meter per second. So you can first of all cut these two here. This is 3 into 10 power minus 1. So automatically you will be getting this one 10 power minus 5 Weber per meter square. This is a vertical component of Earth's magnetic field of Earth. And of course, he has given us what is a horizontal component of Earth's magnetic field as well. What is the value given? 0.3 into 10 to the power minus 4 Tesla. So you can write 10 power minus 4 Tesla into 0.3. That means you can write 3 into 10 to the power minus 5 Tesla. This is a horizontal component and this one is vertical component. What is the question he is asking? He is asking you what is dip angle. If I take dip angle as phi, tan phi can be written as vertical component of magnetic field of Earth over horizontal component of Earth's magnetic field. I just repeat once again, when I consider a dip angle as phi, tan phi must be Earth's vertical component by horizontal component. What is vertical component we have calculated? It is 10 to the power minus 5. What is horizontal component? He has given 3 into 10 to the power minus 5. Now is it not simply 1 over 3 please? So when this value is 1 by 3, directly we can understand dip angle, which is phi in this particular case, is tan inverse 1 by 3 as such. So what we should understand here, if dip angle is phi, then you can write tan phi is equal to BV by BH. I want the value of phi now. So it is tan inverse 1 by 3. See the 4 options please. First option tan inverse 3 by 4. Second option tan inverse 1 by root 3. Third option tan inverse root 3, and fourth option is given the same option, that is tan inverse 1 by 3 given. Therefore, the correct answer for this one will now be the fourth option for us. So one of the excellent concepts here, he is just taking up the effect of magnetic field on the effect of current and magnetic field relation, like in terms of dip he is asking. Electromagnetic induction is the topic what we are dealing with, that now is linked with geomagnetism. One of the major components over there, one of the major parameters to know about geomagnetism at a particular place, that is angle of dip. So that value he is asking us here. This is the formula every one of you can understand, I hope. That is BV by BH must be tan phi, then phi must be tan inverse of this value, that we have got it as 1 by 3. So correct option for this problem number 35 is fourth one, that is D.